Hello friends, this is Jagdish, Perk Associate. Today's topic is gate. So in today's video, I will be explaining a strength of materials numerical problem which was appeared in the gate paper 2003. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers Team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. First, I will read the question. A bar of varying square cross-section is loaded symmetrically as shown in the figure. Loads shown are placed on one of the axes of symmetry of cross-section. Ignoring self-weight, the maximum tensile stress in Newton per mm square anywhere is A 16, B 20, C 25, D 30. Now I will analyze the question. A bar of varying square cross-section, which means a non-uniform square bar. The meaning of non-uniform square bar is a single square bar whose area varies at different section. So you can see here the picture of a non-uniform square bar. This is a single square bar and the area at this section is 50 mm into 50 mm and the area at this section is 100 mm into 100 mm. So the square bar will be considered as non-uniform square bar. Okay. The loads 50 kN, 100 kN and 100 kN are exactly placed on axis of symmetry. So in this question, we have to find the value of maximum tensile stress induced in the non-uniform square bar. Now I will move to the solving technique. For calculation purpose, the non-uniform square bar is divided into two sections, section 1 and section 2. So here is the picture of non-uniform square bar which is divided into section 1 and section 2. So here 50 kN of force will act as pulling force on section 1 and section 2 and 100 kN and 100 kN of forces will act as pulling force on section 2 and pushing force on section 1. So first we will draw the free body diagram of section 1. So the pulling force acting on section 1 is 50 kN and the area of section 1 is 50 mm into 50 mm. Now we will calculate the value of stress acting on section 1, which is sigma 1. The universal formula for stress is force by area. Therefore, stress acting on section 1 is force acting on section 1 divided by area of section 1, which is sigma 1 is equal to P1 by A1. We know the values of P1 and A1. So just substitute the values, we can easily get the value of sigma 1. So sigma 1 is equal to 50 kN divided by 50 mm into 50 mm. We know that kilonewton is 10 power 3 Newton. So this 50 kilonewton will be rewritten as 50 into 10 power 3 Newton. And 50 mm into 50 mm is 2500 mm square. Okay, so this RHS will be rewritten as sigma 1 is equal to 50 into 10 power 3 Newton divided by 2500 mm square. So 50 into 10 power 3 Newton divided by 2500 mm square is 20 Newton per mm square. Therefore, sigma 1 is equal to 20 Newton per mm square. But Newton per mm square is megapascal. Therefore, sigma 1 is equal to 20 megapascal. Consider this one as equation 1. Now we will draw the free body diagram of section 2. So the pulling forces acting on section 2 are 50 kilonewton, 100 kilonewton and 100 kilonewton. So the total load acting on section 2 or the total pulling forces acting on section 2 is P2 is equal to 100 kilonewton plus 50 kilonewton plus 100 kilonewton, which is 250 kilonewton. And the area of section 2 is 100 mm into 100 mm. Now we will calculate the value of stress acting on section 2, which is sigma 2. So the universal formula for stress is force divided by area. Therefore, stress acting on section 2 is force acting on section 2 divided by area of section 2, which is sigma 2 is equal to P2 by A2. So P2 value is 250 kilonewton and A2 is 100 mm into 100 mm. Therefore, sigma 2 is equal to 250 kilonewton divided by 100 mm into 100 mm. We know that kilonewton is 10 power 3 newton. So this 250 kilonewton will be rewritten as 250 into 10 power 3 newton. And 100 mm into 100 mm is 10,000 mm square. So this RHS will be rewritten as sigma 2 is equal to 250 into 10 power 3 newton divided by 10,000 mm square. So 250 into 10 power 3 newton divided by 10,000 mm square is 25 newton per mm square. So sigma 2 value is 25 newton per mm square. But newton per mm square is megapascal. So sigma 2 value is 25 megapascal. And consider this one as equation 2. Now we will compare equation 1 and equation 2. What is equation 1? Equation 1 is the stress acting on section 1, which is sigma 1 is equal to 20 megapascal. And equation 2 is stress acting on section 2, which is sigma 2 is equal to 25 megapascal. By comparing these two equations, we can conclude that sigma 2 is greater than sigma 1 because sigma 2 value is 25 megapascal and sigma 1 is 20 megapascal. So 25 megapascal is greater than 20 megapascal. From this equation, it is clear that the maximum tensile stress is induced in section 2. And also the maximum tensile stress of non-uniform square bar is 25 megapascal. So option C is the right answer. You can see here, among these four options, C holds the value of 25. So the maximum tensile stress induced in non-uniform square bar is 25 megapascal. Okay. So this brings an end to the explanation part of this problem. I hope you all would have understood. If any doubts are there, please do comment in comment box. And remember to like, share and comment on our videos. Thank you friends.